What's up YouTube? My name is Dylan. Today I'll be showing you how we ran power, internet, and water down to our barn. 8 years ago when we purchased our family farm, we got a pole barn built. We recently ran out of space and got an extension built on our pole barn. And now we're ready to invest the time to run power. We start off the project by firing up the backhoe and digging the trench. Nick got a little excited here and started digging the trench before setting up the GoPro to start filming it. So we missed the shot of digging the trench on the side of the barn where the wire connects. We originally thought about renting a trencher to dig the majority of this trench. Our backhoe has a 2-foot wide bucket on it, so it's an awfully big trench for something as small as a power wire. Turns out we made the right choice. Not only is using the backhoe free, but as you can see, we pulled out rock after rock, just hitting slabs of rock the entire trench. All of these little rocks here that are scattered about came out of this trench. This is the shot we missed, the original trench dig behind the barn. We came back later and decided that while we were running power, we might as well run some water down too. So this first hole here is for where we'll put a sink in, and then the second hole is for where our power is going to run in. We also dug the trench all the way to the back of the barn. That way we could run the water line down and put a water spigot in. The trench from the barn to the house is about 210 feet. Then we need a little bit of extra to run into the barn, and about 30 feet of extra to run across the house to where the breaker panel is. So we ended up getting 250-foot lengths for all of our wires. Warning, I am not an electrician. I'm just a guy on YouTube. Always make sure to check with an electrician to make sure that you're running the correct size wire and have everything hooked up correctly. You can get a code manual book, and that should guide you through most of what you need to get things set up correctly. The sub panel that we're installing in the barn is actually just a standard house panel. The only difference is there is no screw bonding the ground and the neutral together. I put a single screw in the panel, that way we could align it and figure out exactly where it needed to go. Then I used a very long drill bit to drill through the plywood and through the outside sheet metal of the barn. Prior to this shot, I left the drill bit sticking out the backside so it was easier to find. Then I tried to come back through with a hole saw bit. I thought it would be pretty easy to cut through the metal, and it ended up being nearly impossible. Not sure if this thing was dull or if it was just too hard to get enough pressure on the side of the building.
Need more ass.
Instead, what I ended up doing was drilling through the plywood on the inside with the hole saw bit, and then on the outside, cutting through the metal with the jigsaw. After punching out the hole in the top of the box, we realized that it's not actually big enough for this 2-inch pipe that we have coming in. So I sharpied a mark to the next size and jigsawed that larger as well. I went ahead and put the PVC male through the back of the box, make sure it fit in my hole correctly, and line everything up and install the panel for real this time. I'm going to use a level, make sure it's good and square. To bridge the gap between the plywood and the wall, we're going to use a short section of the 2-inch PVC. So it'll be male, short bit of PVC, and then an LB box on the outside of the barn. I loosened up the first screw and then got the level good and set, and then tightened that back down. I don't know how many screws are required by code, but I just put a bunch in there. On all the PVC coming into the panel, I put a lock nut on there and then put a plastic bushing over the threads to protect your wires. With that, we'll call the panel installed, and now it's time to move into the house and install our conduit for our wire to run through. We counted the number of cinder blocks from the outside of the house to determine which block we wanted to go through, and then we drilled the hole from the inside to the outside to make sure everything lined up correctly. From there, I drilled a series of holes all the way through both sides of the cinder block around, and then punched them out with a hammer and a chisel. I'm pretty sure this box is 6 by 6 by 4, and I used a hole saw to drill 2 holes for my 2-inch conduit to come through. One piece goes through the wall, and then the 90 will go up against the ceiling and then run a straight over to our panel. Once I was happy with the dry fit, I took some PVC glue and glued my individual sections together. With my straight piece screwed in, I went ahead and put that through the wall, checked it on the outside to make sure it was in the correct location, the length was good, and then I used some Tapcons to screw the box into the concrete wall. Running the PVC above us on the ceiling was the path of least resistance. The only thing we needed to move was one block of cribbing, and when we were done, we just cut a U and went ahead and put one of those back in. Our conduit is going to come out the top left side of the panel, up, and then across the ceiling here in the gap in between the floor joists, all the way to the exterior wall. This had a 2-inch punch out on the side, so I went ahead and knocked that out. Got a male adapter stuck in there with a lock nut and a bushing, so it's all ready to go. Nick fired up the hole saw and cut a 2-inch hole in one of our floor joists so we could stick our PVC through there. For the most part, we were able to connect everything with straights and these large sweeping 90s that you can buy. These should be a lot easier to pull all of our cables through. For the one piece that required something custom, like a small sweep, we ended up using a heat gun and heating up the pipe and just kind of bending it into an S and then chopping it to the length that we needed. It's not the prettiest thing in the world, but it got the job done, and there's still plenty of room inside for our cables. This is what the dry fit looked like. My dad thought it would be a good idea to cut a hole saw in another board and go ahead and sister this joist where we weakened it. The reason we have a little box here is because we're actually going to switch from aluminum cable to copper cable for these last little legs going into the panel. A 70 amp breaker only allows such a certain size cable, and with a 250 foot run length, we have quite a bit of voltage drop, so we need a pretty big wire. Once the location of the box was marked, I went ahead with the hammer drill and drilled some pilot holes for a few Tapcons to hold the box. Now all the individual pieces have been glued together, the box is attached, and all of the lock nuts and bushings are installed. Alright, that's dry fit. I think we'll be good. Once the two 90s were in place and glued up, it was a straight shot from here to the other side. Our next step is segmenting our wire. In order to make this affordable, we ended up running aluminum cable, and we ended up getting a 750 foot length to run all of our primary cables. So we're going to stretch out 250 feet and chop it 3 times for our positive, negative, and neutral. Our fourth wire is our ground wire. That is a number 2 aluminum instead of the 1 out for the primary conductors. The outside PVC box here is called an LB style, and then the piece of PVC that we're running into the ground is required to be schedule 80, so that's extra thick. I picked up a direct burial Ethernet cable from Amazon. This is also supposed to be shielded, so it should allow us to have Wi-Fi down at the barn. I taped this up to the other wires and ran it right alongside them. Our plug-in for our router is right next to where our power panel is, so easy to run both of them in the same conduit. We measured inside the house and came up with we needed about 30 feet of cable, so we stuck that much in before we tried to pull it through the conduit on the inside. We used some electric tape every 4 or 5 feet to connect the wires together so that they acted like a bundle and weren't as willy-nilly. We ran a fish tape through the inside conduit and then taped it to the end of our wire and started pulling. This was an absolute nightmare and took forever for the 3 of us to pull this cable through, but we did eventually get it pulled. With the cable safely through, we went ahead and put some clamps on our PVC to put it in its final resting place. We pulled the rest of the excess back through the hole to the outside, and then I did the best that I could to make a solid round loop in the wire there. If I did it again, I'd probably use a larger box for this, just so that I could have a larger loop or a better angle on the wire. Alright, that guy's all connected. The hardest part is over. Our wires are successfully run through our conduit, and our conduit is all screwed down in its final place. On the outside, we didn't glue the box or anything in. That way it was easy to shimmy the cable through, and then we could reattach everything. The box got PVC cemented into the pipe coming through the wall, and then we went ahead and hammer drilled in some tap cons to hold the box to the wall. The box had a little bit more stick out, so there was a gap when we tried to pipe clamp this hose to the exterior wall. So we put a little wood shim behind it and then tap conned it in. We zip tied the rest of the wires together every 5 or 6 feet or so and laid the wire in the trench. Now it's time to run the wires through the box on the barn side. We used the exact same setup for this and somehow missed filming it when we were doing it in the dark. But same setup. We're going to attach this LB and then glue that to the piece of straight pipe that comes through the wall. With our wires poking through into the panel now, it was time to install the ground rod. I'm pretty sure the code book said you only need a 6-footer, but they sold it as an 8-footer, so we went ahead and just pounded it in there anyway. It took forever, but eventually we got it in there. If you're running a subpanel to an exterior building like this, you are required to have a separate ground rod. You can use bare copper wire to this if it's a certain size, and we just went ahead and grabbed a clamp from Home Depot that attaches it to your ground rod. Now we're using the fish tape to pull our copper through our pipe, and then we'll connect it at the bottom, and the rest of the slack will go through the panel to the inside. Here's the wiring diagram that we're going to follow. From the house, we have our 2 hots coming from the breaker. We have a neutral and a ground coming from the bonded neutral/ground bar. On our sub panel, we're going to have a dedicated ground bar, a dedicated neutral bar, and then our 2 hots are going to come into the top of our panel as our main. This panel doesn't come with a separate ground bar, so I went ahead and picked one up with a bunch of spaces, and I'm going to install it on the left side of the panel here. The ground bar will end up attached to the ground of the house, and also our local bare copper ground going to the rod outside. Now it's time to cut all of our cables to length and install them. First one I'm going to cut down is the ground cable, and I slide it all the way up to the top, that way to make sure I have plenty of extra when I cut this. I'll cut it to its final length when I go to install it. The first cable I ended up installing was the neutral. It was marked on the end with white tape, and I'm going to put some white tape inside of the box so that it's clearly designated as the neutral. I put a loop in all of our wires coming in the top of the box. It's referred to as a service loop, and it gives you a little bit of extra cable should you need to redo the end or change something in the future. All of my power feeders are aluminum cables, so all of these connections where the wire is stripped needs an antioxidant compound applied. You want to tighten these cables down, give them a wiggle, and tighten them again a few times to make sure they are nice and snug. Next, I attached our bare copper ground wire to the bottom of our new ground bar. I made sure to put some white tape right around the end of the neutral to designate it. I also took a white paint marker and marked which way it was on and which way it was off on the main breaker. Next, I cut down the two hot wires. It doesn't matter which one goes to which side of the panel. With this panel technically being a house panel and not a sub panel, we have a nice on-off breaker at the top so we can shut off all the power in the building with one easy switch. The ground wire from the house is too big to connect directly to the ground bar, so you put in one of these guys and it allows you to put a thicker wire in there. This one goes sideways, but it was replaced later on with one that goes straight. I'll show you that, but that nice shot had it with the crooked one in there. My dad wired up a quick test outlet. That way when we connect to the house, we can verify it works. I put the plastic cover over our two hots to protect you from getting zapped, because those are on, even when the switch at the top of the panel is off. I went ahead and connected the wire running to that outlet to a breaker and slapped it in the panel. This is just for a test, and that's why our ground wasn't long enough, so I went ahead and wrapped an extra one around it to connect it. And like I said before, I got the correct fitting here, and it takes the wire in through the top instead of the side. That way my ground wire from the house isn't anywhere near my breakers. The first thing that I plugged in was our Ethernet cable. I just used a regular Romex clamp and lightly clamped on the cable to hold it in place. Now we're back at the house and it's time to connect all of our wires. All four wires were running out of the junction box here. The reason there was a junction box is because our 1/0 aluminum feeder will not fit into our 70 amp breaker that we're installing. So for our 2 hots going to the breaker, we're going to pare that down to 2 gauge solid copper. At this point, it's time to kill the power to the house, or at least shut it off at the panel. The lines coming in from the utility pole are still and always will be hot, so make sure not to touch those. All the light here is coming from a generator, and then we set up a couple lights so that we'd be able to film and see what we were doing. I thought it might be easier to connect our 2 hot wires outside versus plugging the breaker in and then trying to install the wires. For both our neutral and ground wires, we're going to use these large lug adapters. They take up 2 spaces on the neutral/ground bar. I say neutral/ground because the two are bonded together and they act as one. So we could technically use any of these bars to connect our ground and neutral wires to. We, for convenience, put one on the left side and one on the right side just so that we'd have good cable management. On the left side here, we're going to connect our ground. This is a 2-gauge aluminum instead of the 1/0 that our primary conductors are. I was pulling off the rubber there and yep, just pulled that razor blade across my finger. Got a little bit of a gusher, so had to go grab a Band-Aid. Just like our other connections, going to make sure to put some ox guard on the aluminum. I used a bit of white electrical tape to designate our neutral before installing that wire. And then with all these connections, it's a good idea to tighten it up, wiggle the wire back and forth some, and then retorque it a few times. That way it's nice and tight, and the future wiggling won't loosen up the connection. The breaker was a bit of a pain to install, and what made it easier was taking out the breaker on the other side of the panel. That might have been making it hard, and eventually we got it in there, and then we were able to reinstall the adjacent breaker. My dad drilled a hole out for the Ethernet cable to come out through the box. The router's right there on that table. I chose to do this connection here last, that way I could have the perfect amount of slack in my cables that went to my breaker. To connect these two together, I'm going to use these cool connectors from Amazon. They allow you to connect 2 different size wires, and that'll be real easy in this junction box. Once the 4 wires were stripped, it was just a matter of tightening down the lugs. It does come with dielectric grease in there. For the aluminum, I went ahead and put the stuff that I had used before on there too, just as a little extra insurance. I had to recut the second pair a little bit shorter to fit inside the box. Everything is now officially connected, and we can put the covers back on this little utility box and the panel, and then fire it up and see how we did. I flipped the breaker that feeds our sub panel, and then I headed down to the barn. From there I flipped the master switch on the panel, and our single outlet that we had, flipped the breaker on that, and our light lit up, so we have power. Then I used one of those little plug-in checkers to make sure everything was wired correctly. Then I plugged in our router, got the internet going. Now that we know everything works, we're good to bury our wire. I'm not an electrician, so we wired everything together before we started backfilling the trench at all. That way we knew everything was correct and everything was good before we finalized anything. We started by hand filling it with some dirt on top of our wire. Officially, you're supposed to use gravel for this, but gravel costs money and dirt is free. Once we had a safe cap of maybe 4, 5, 6 inches of dirt across the whole wire, we were ready to run our caution tape. This will hopefully stop us from digging into the wire, or somebody else in the future digging into the wire if they dig. Now that we got power and internet run down, it's time to run our water line. We're going to use the exact same trench for this, and we chose to put it on top of the power wires because we figured if we had a problem, it was most likely going to be with the water, not with the electric wires. This is PEX tubing, and the correct thing to do is to unspool it, that way it doesn't come off all wound up like that. We managed to do that for the wire, but somehow brain farted and retardedly pulled it off and then fought it for the entire length of the trench. We held the tubing down with rocks and we put in a T where we're going to put our sink. And then we ran the line all the way to the back of the barn where we'll put a spigot for washing machines and dirt bikes. Once everything was all buried, one other thing I did was came back with some duck seal and went around with a snake around both of our boxes, the one at the house and the one going into the barn. This is like a soft, almost like a hard Play-Doh putty, and you put it on there and then it'll kind of air dry and get hard over time. Use the same stuff to seal around the water pipe where it was coming out of the house, and that should give us a pretty good seal from the elements. In the middle of this project, we bought a bulldozer for the motocross track, so we're going to go ahead and use it to backfill our trench now that our water line is laid in. At this point, we had just got the machine, so it was pretty scary for Nick here to back over the trench. Once he was on the far side, it was pretty easy for him to push the dirt back into the trench. At this point, I'm sure you're thinking, hey, they're doing a terrible job. They're just putting all the soft dirt back into the trench, and that's going to sink and settle down. You definitely need to pack the dirt when you're putting it back in the trench. The reason we didn't bother is because we need to regrade this whole area behind the house. So we have the liberty and the machines readily available where we can grade this out and then wait a month for it to settle and pack in, and then we'll come back and get a final grade on it. The PEX tubing at the end of the trench here will be for our water spigot, and then the other PEX tubing teed off on the side will be for a sink in the first barn. If you're doing a project like this and you leave a cross slope open without putting any grass seed down, you're going to end up with what we have here, which is an absolute waterfall coming down our trench. We planned on leaving all of this to settle, but we didn't think about the fact that the clay hillside was above our driveway, and now we have a bunch of grass and weeds growing in our gravel. The correct thing there, if we were using our same technique, would have been to put up a silt fence. We didn't throw any grass seed. This is just all the weeds and surrounding grasses that have kind of come in the couple month span between when we first did this and when we're coming back now to put the final grade on. The rain rut here is 6 inches, maybe 8, 10, a foot deep in some spots where that little waterfall was. So I start here by just cutting all the grass on the hillside so we can see what we're working on. Then we're going to push some dirt back into our trench and pack it in good. We've wanted to grade behind the house here for a while, but we're kind of dreading it when all we had to use to do it was the tractor. The plan is to have it slope away so that the water runs further away from the house and it's easier to pull a side-by-side or a vehicle around the back of the house if you need to. We also took this opportunity of everything being ripped up to go ahead and knock some of the top of this hill off so that it's easier to mow and make a path into the upper pasture that wasn't there previously. We missed the shot, but as soon as the trench was filled in initially, we rolled through it with the backhoe to pack it in, and then once the entire area was graded, everything got rolled in with the backhoe again. That machine's pretty heavy, so it does a great job at compacting everything. And then we brought in some black dirt that we harvested from elsewhere on the property. That way we can get some grass growing back here. Now that everything has a nice thin layer of topsoil on top of it, I ran through everything with the tractor. This rolls everything in to pack it and also leaves little tire treads. The tractor has ag tires on it, and that works out perfect to hold the grass seed in while it sprouts. Nick ran around and threw some seed on it. We just threw some annual ryegrass on there, and the native grass will kind of fill it in over time. Just a few weeks later, all of our grass had sprouted and everything looked really lush and green. The side of the barn is still solid clay. That didn't get the same black dirt and grass treatment. For there, we're going to eventually gravel the whole thing. That way we have a road around both sides of the barn. But for now, it's just solid clay. Over the next year or so, we put in light switches and a whole bunch of circuits. We put outlets on all the posts all the way around, as well as some extra ones where the workbenches were. Both the front and the back side of the barn have independent light switches for the overhead lights. Here's a full breakdown on all of our costs. Our wire was $1,200. At Home Depot, we picked up our PVC conduit, all of our boxes, breakers, light switches, outlets, all the odds and ends, and 300 feet of PEX tubing. And our grand total was just under $2,500. The excavation was essentially free. It only cost diesel because we already owned the machines. Here's my exact wire order. We have 1/0 aluminum, that's our feeder cables, our 2/0s and our neutral. We have 2-gauge aluminum, that is our ground that runs to our sub panel. The 500-foot coil of 12-2 Romex is our interior 20-amp circuits. The 6-gauge bare copper wire goes from our sub panel to our ground rod, and the 12-foot of 2-gauge copper is used for our junction box to cross over to our 70-amp breaker. With tax and shipping, it worked out to $1,200. They shipped it UPS and they dropped it off on a miniature pallet. Our channel is typically focused around dirt bike track building, riding, and fixing our heavy machinery as it breaks along the way. If any of that sounds interesting, give us a subscribe. That's all for this one. We'll see you next time